This is a video answer key for the Module 4 test, Honors. Problem 1 is finding the slope of the line. I'm going to draw a horizontal line or arrow and a vertical arrow from one point to the other. This is positive 5 because it's 5 to the right. This is positive 2 because it's 2 up. So the slope is rise over run, which is 2 over 5. For number 2, I'm going to make a arrow downward and an arrow to the right. It's down -2 and to the right 2. The rise over run is -2 over 2, which is -1. Number 3 is graphing a linear equation using a table. The rule is -2x plus 1. So if x is -2, we have -2 times -2, which is +4, plus 1, which gives us 5. If x is -1, we have -2 times -1, which is 2, plus 1 is 3. If x is 0, we have -2 times 0, which is 0, plus 1 is 1. If x is 1, we have -2 times 1 is -2, plus 1 is -1. And for 2, we have -2 times 2 plus 1, which gives us -3. So our ordered pairs are -2, 5, -1, 3, 0, 1, 1, -1, and 2, -3. So we're graphing these points left 2 and up 5, left 1 and up 3, 0, 1, right 1 and down 1, and right 2 and down 3. That makes a line like this. Number 4 is graph using the slope and y-intercept. So for number 4, we have the slope of -1/2 and the y-intercept of -2. We go down to -2 on our graph for the y-intercept, and then it's run 2 and rise -1. Since we have rising and negative, it's going down. So from here we run 2 and we rise -1, which is down. We can do that again and again, and then we draw our line. For number 5, we have the slope of 2, which is 2 over 1, and the y-intercept is 3. So we're going to go up to 3 on the y-axis, and then we're going to run 1 and rise 2 from this point. Run 1 and rise 2, run 1 and rise 2 gives us a line like this on our graph. On the other side of this paper, we have problem 6. We have to read this carefully. A dolphin was 15 feet away from a shark. It swam away from the shark at a steady rate of 35 feet per second. Find out how far the dolphin would be from the shark in the amounts of seconds given in the table. So the dolphin starts out 15 feet away from the shark, but goes 35 feet per second. That's pretty fast. So every time we're going to be adding 35. So 35 plus 15 gives us 50, plus 35 is 85, plus 35 is 120, plus 35 is 155, plus 35 is 190. How far away from the shark would the dolphin be if it kept up the steady pace for a minute, which is 60 seconds? Well, we know it goes 35 feet per second, so it's 60 times 35 plus the initial 15. How far away from the shark would the dolphin be in X seconds? Well, here we multiplied 60 by 35 plus 15. So down here, it's going to be 35 times X instead of 60 plus 15. I just realized I forgot to simplify this. 60 times 35. I'm going to multiply 6 times 35. I get 210, so that's actually 2,100 plus 15 gives us 2,115, or 2,115 feet. It says write this expression in the blank column of the table and test to see if it works in the XY column with the ordered pairs and plot the points on the graph. Draw the line, label the X and Y axes appropriately. So up here I'm going to write 35x plus 15. 35 times 0 plus 15 is 0 plus 15 is 15. That's correct. 35 times 1 plus 15 gives us 35 plus 15, which is 50. 35 times 2 plus 15 is 70 plus 15, which is 85. 35 times 3 plus 15 would give us 105 plus 15 is 120. 35 times 4 plus 15 is 140 plus 15 gives us 155. 35 times 5 plus 15 gives us 175 plus 15, which is 190. So the XY pairs are verified to be 0, 15, 1, 50, 2, 85, 3, 120, 4, 155, and 5, 190. To graph this, I'm going to have on my x-axis is going to be seconds. And on my y-axis, I'm going to put feet. I'm going to have each division going on the y-axis to be 10. I'm just going to label every 20, 20, 40, 60, 80, 100, 120, 140, 160, 180, and 200. There we go. Here we're just going to go 1, 2, 3, 4, 5. So we have 0, 15, just right here, 1 and 50, 2 and 85, here's 80, here's 90, so here's 85. We have 3 and 120. We have 4 and 155, and 5 and 190. So our line goes somewhat like this. Sorry, it's a little off right there. Should have used a ruler. Okay, so it says right now, what is the slope of the line and what does it mean in the problem? Well, I can use any 2 points. So what I'm going to use is this point right here, and I'm going to use this point right here. So this arrow is going from 1 to 3, so it's obviously 2. Going from here to here, we're going from 50 to 120, so that's 70. 70 over 2. We can't count the spaces because we've changed our scale to 10 for each division. So we have 35. The slope is 35, and what it means is the dolphin is swimming 35 feet per second. What is the y-intercept? It's where the graph meets the y-axis at 15. So we're going to write 15, and that's because the dolphin starts out 15 feet away from the shark. So the equation of the line simply is putting a y equals in front of the expression we have 35x plus 15. We have the last page. Complete the representations and determine if the following are proportional relationships. Down here it looks like we have time and water used. So we're going to say that for the description, we are using, and we look down here, every minute it's using 5 gallons. 5 gallons of water per minute. Going over to our chart right here, it'd be pretty easy to graph this. We're going to have the x-axis as time in seconds and the y-axis as gallons of water. 1, 2, 3, 4, and over here I'm just going to go ahead and use every I think I'll just go one by one. So 1, 2, 3, 4, 5. Here's 10. It's going to go a little bit off the graph, but that's okay. So we have 0, 0, 1, 5, 2, 10, 3, 15. So here's our graph. All right. Going back to see the ratios, going back here we have it's y over x, so we have 5 over 1, 10 over 2, 15 over 3, and 20 over 4. All of those equal 5, which means the constant of proportionality is 5. To find the slope, I'm drawing a horizontal and vertical line. This is 1, and this is 5. So the rise over 1 is 5 over 1, which is 5. So the equation is y equals 5x, because the slope goes before the x, and the y-intercept is 0, so we don't have to write anything than that. Is this a proportional relationship? It sure is. The main reason is because all of the y to x ratios are 5. Yes, because all the y to x ratios are equal, and they're all 5. Another reason could be it's a straight line going through 0, and also it's in the form of y equals mx with no b. The second one of this kind, an electrician charges $20 for a house call plus $40 per hour. So at 0 hours it would still cost $20 just for the house call. For 1 hour it'd be $20 plus 40, and for 2 hours it would be another 40, which would be 100. 3 hours would be another 40, which is 140, and then for 4 hours would be another 40, which would be 180. Now let's go to the graph. We have the x-axis, which would be hours, time in hours. The y-axis would be the cost in dollars. We're going to have to do this one a little bit differently. Maybe we can have every section as being 10. So here we have 20, 40, 60, 80, 100, 120, 140. Not all the values will be on the graph, but it'll be okay. So we have 0, 20, 1, 60, 2, 100, 3, 140. I'll label these 0, 1, 2, 3, 4 goes off the graph, but it does make a straight line. Going back here, the y to x ratios are 60 over 1, 100 over 2, 140 over 3, and 180 over 4. If just two of these are not equal, we know the whole thing is not proportional and there's no concept of proportionality. 60 divided by 1 is 60, 100 divided by 2 is 50. Just because those are not equal, then there's no concept of proportionality. We can still get the equation, the slope, here's 1, and going from 60 to 100 is 40, so it's 40 over 1. So our equation is y equals 40, since 40 is the slope, x, and the y-intercept is 20, so it would be plus 20. Is this a proportional relationship? No, mainly because not all the y to x ratios are equal. We could also tell by the fact that it's a straight line, but it doesn't go through the origin. It has to go through the origin to be proportional, and it's in the form y equals mx, but there is a b there. If there is a y-intercept, then it's not proportional. These two graphs right here might look different if you've used a different scale, but either way you do it, you should get the same slope and the same results. That's the end of our video answer key. Thanks. Bye-bye.